In lesson 2.1, we're going to learn the basics of how to set up, run, and analyze a hypothesis test. This is probably one of the most important topics we're going to cover in this course and something that we're going to come back to over and over again in different forms. And in chapter 2, you're just going to be introduced to kind of the format of the tests and how we conduct each of the different parts. Lesson 2.1 is just kind of an overview of all of these steps. So we're still working with categorical data in chapter 2. And remember, we use what's called a two-way table to display the distribution of a categorical variable in at least two different contexts. As an example, in the 2014-15 season, the West Ottawa men's basketball team won 9 games and lost 1 at home, but they only won 5 and lost 3 when they were playing in away games. From this information, it seems like there might be what's known as a home court advantage in basketball. But we want to know if this difference that we see with West Ottawa's team is convincing enough evidence for us to conclude that there is, in fact, a home court advantage. What we're going to do is organize this data into a two-way table, and we're going to make a segmented bar graph. So let's start with home games first. We know that during the season, they won 9 games and they lost 1 playing at home. That means that in home games, they had a total of 10 games. In away games, they won 5 and lost 3, which means they played a total of 8 away games that season. Now we can total up their win and loss record. 9 plus 5 gives us 14 wins. They had 4 losses in that season for a total of 18 games. Now, when we make our segmented bar graph, we want to separate the data into home games and away games. So for home games, we know that they won 9 out of 10, which means their home winning percentage is 0.900. We're going to go to 3 decimal places in this chapter again. For away, they won 5 out of 8, which is 0.625. So when we make our segmented bar graph for home games, the portion that represents winning games, we need to go all the way up to 90%. And then the remaining 10% were games that they lost. For away games, that portion of the bar is going to go up to 62.5%. And then the rest of the games would be losses. Don't forget, we need to do key. So I'm using yellow for loss and purple for wins. So based on the graph, it does appear that they have a greater ability to win games when they're playing at home. But again, we want to know if we have convincing enough evidence to say for sure. So based on the graph, what appears to be true? They seem to win a greater percentage of games at home than away. So even though this graph gives us some evidence that there's a home court advantage, it might be that they actually have the same ability to win home games and away games, but their performance was a little bit different in away games simply because of random chance. And that's what we want to look at today. And that process is called a hypothesis test. So really what we're examining here are 2 claims. Claim number 1 is that West Ottawa's basketball team had the same ability to win in home games and away games, and the difference was due to random chance. Claim number 2 is that the basketball team had a greater ability to win in home games than in away games. We are going to assume that claim number 1 is true unless we have convincing evidence that claim 2 is true. Now, a little bit of vocabulary that goes along with hypothesis test. We had 2 claims that we just discussed, and the names of those claims are the null hypothesis and the alternative hypothesis. The null hypothesis we abbreviate using the symbol or the notation H sub 0. And that is our initial belief that there has been no change in ability or that there is no difference in ability in 2 contexts. In other words, they have the same ability to win whether they're playing at home or away. Just to kind of give you another situation, you might look at baseball players and say they have the same ability to get a hit whether they're facing a left-handed or a right-handed pitcher. That's 2 different contexts. The alternative hypothesis describes what we want to establish or what we suspect is true. So maybe we have evidence, for instance, that West Ottawa wins more games at home than away. Or maybe we have evidence that baseball players get more hits against right-handed pitchers than left-handed pitchers. So we suspect that something else other than our null hypothesis might be true. Now, the hypothesis test is the formal process used to decide whether the data provide convincing evidence to support the alternative hypothesis. So we're going to assume the null hypothesis is true. If we have very strong evidence of the alternative, then we will say that that's probably true instead. A test statistic is a measure calculated from an athlete's or team's performance that is used as evidence in a hypothesis test. And we'll come back to that in just a minute. And then finally, the p-value, in this case, p stands for probability. So the p-value measures how likely it is to get a test statistic equal to or more extreme than the observed test statistic just by random chance, assuming the null hypothesis is true. Now, I know that all this vocabulary seems pretty ambiguous right now and kind of vague, and it'll become more clear as we use it in some examples throughout the chapter. All right, so let's go back to our question about West Ottawa basketball. So we want to know, is there a home court advantage? Now, the way that we would state these hypotheses using kind of like a correct statistical format is we would say our null hypothesis, the HO there, is that West Ottawa men's basketball team has the same ability to win in home games or away games. We're going to just assume that that's true, right? They have the same ability in both contexts. Our alternative is what we suspect, which is that West Ottawa's men's basketball team has a greater ability to win in home games than away games. And our hypotheses are always written in terms of ability. Now, our second step is going to be to calculate a test statistic. And what we're looking at in this chapter is the difference in winning percentages. And we're going to do home minus away. So remember, we already calculated the home winning percentage to be 0.900. We know that the away winning percentage is 0.625. We calculated that earlier. And so our test statistic is the difference there, which is 0.275. So because we define that as home minus away, we get a positive value here. And that means that basically they win 27.5% more of their home games than away games. And that's seems like a pretty significant difference. Now, we're going to kind of run a simulation, and I'm going to show you two different ways to run that. So the total number of games they played in the 2014-15 season, remember we said was 18 games. Their final record was 14-4. Their overall records of wins and losses was 14-4. So when we run our simulation, we're going to use 18 cards. And I'm going to do the simulation for you. You don't have to actually get cards out. And we're going to let black cards represent a win and red cards represent a loss. So we would need to pull out 14 black cards and 4 red cards. Now, the number of home games they played was 10, and the number of away games they played was 8. Now, the directions in your notes say to write W or L on an index card, but I would probably just do this with a regular deck of playing cards, which is why we're doing red and black. So again, they played 10 home games, they played 8 away games. So what we would do is we would shuffle the cards really well, and we would split them into 2 piles, a home pile and an away pile. So we'd do a pile of 10 and a pile of 8. And we would see how the wins and losses would fall just by chance. Like if we shuffled them up and it really didn't matter whether they were playing home or away. So let me just do that for you and show you what that would look like. So first I'm going to make a home pile with 10 cards and an away pile with 8 cards. So remember I started with 14 black and 4 red cards. So let's say I shuffle them really well and I start dealing them out. And there's 5, 6, 7, 8, 9, 10. So there's their 10 home games for that season. Notice out of those 10 home games, they won 8 of them because there are 8 black cards in that pile. Now, the remaining 8 cards that are left in my deck would be the away games. And out of those 8 away games, they won 6. All right, so just to kind of summarize here, they had 8 wins and 2 losses at home, 6 wins and 2 losses when they played away. Now, we can summarize that in this little table. So again, we had 8 and 2 home games. We had 6 and 2 for away games. So winning percentages, they won 8 out of their 10 home games, which would be 80%. Not quite as good as what the actual basketball team did, but still pretty good. In away games, they won 6 out of the 8 away games they played, which is 0.75. And then the difference there now is only 0.05%. Or I'm sorry, 5%, right? So now the difference between home and away is only 5%. in West Ottawa's season, they had 27.5%. So we had not quite as big a difference there. Now we could do this again, and we would ideally want to do it many times. And if we were in class together, we would each maybe do it 2 or 3 times and get a good dot plot going. But since we're not in class, I'm going to show you the applet, and we'll just simulate many trials in that way. So this is an applet that we're going to use in this chapter. And what this does is it simulates a difference in proportions. So notice here I have context 1, which we're going to say is home games. Context 2 is away games. And I put in what West Ottawa actually did. So remember, in home games, they actually won 9 out of 10. In away games, they won 5 out of 8. Right? And then, like we've done in the past, we're going to run 100 simulations. And what the applet is essentially going to do is like shuffle those cards up and deal them into piles for us, and then calculate that difference. So we'll click Add More Trials, and we get this dot plot. Okay, so notice here in my dot plot, I've got this line 0 right in the middle. And let me move this out of the way so we can see a little bit better. So 0 right there is kind of separating. Notice we've got some cases here where we've got a negative difference, some cases over here where we got a positive difference, right? And so we want to think about why that's important and how we came up with negative differences. Remember, we're doing home minus away. So if they actually win a greater percent of games away than they do at home, you will end up with a negative difference. And notice that happened in many of these cases. These dots right here are all piled up at 0.05, which is what we got when we did the card simulation. These dots over here are all piled up at 0.275, which is the result that West Ottawa actually got. All right, so let's go back to your notes and let's kind of fill in a couple things here. So we did this already. And then we want to copy the dot plot. So I would recommend that you just copy the one that I made. In fact, I'll go back and maybe take a screenshot of that real quick. So we have that to refer to again. All right, let's go back and paste that in here. And there's our dot plot. Okay. And so again, remember you've got 0 in the middle, and these dots right here are all piled up at 0.5. Again, the exact number of dots is not super important, but just kind of get an overall shape of what that dot plot looks like. Now, in this case, like we said, the negative values on the dot plot represent simulations where they won more away games than home games. And depending on how you shuffle the cards when you ran your simulation, you might end up with that exact result. Now, the dot plot shows the possible differences home and away that we would expect to see if there was no difference in the men's basketball team's ability to win home or away. So now it asks, how likely is it that the difference in their home performance is equal to or greater than the actual difference of 27.5%? So if we go back and look at our dot plot again, let me go back one screen here. We would want to count up how many dots ended up in our simulation at 27.5% or 0.275 or above. And when I look at that, it looks like about, let's see, maybe 17 dots there, and we can actually count it using the applet if we wanted to. So here where it says how likely is it, right, we can write that in. We know it's about 17% because we had 17 dots out of 100 that had that result. So the conclusion that we can make then is that it's likely, sorry, there's a typo there. It's likely that the difference, home minus away, happened just by random chance. That means that there is not good evidence of a home court advantage for West Ottawa. And that is the end of that lesson. Email me if you have any questions, and I will see you guys next week.